When repairing or troubleshooting a circuit, a multimeter is your best friend. How's it going, buddy? A multimeter is like a stethoscope for electronics. It takes abstract concepts such as voltage and current and makes them real by giving us the ability to measure them. This particular model is a manual range digital multimeter. Manual range meaning that I need to set the particular range of values I want to measure, and digital as it uses a digital display to show reading. Auto range meters, like this one, allow you to set the type of measurement you want to make without the need to specify a value range. Analog meters don't use an LCD. Instead, they use an old-fashioned mechanical needle to display their values.
Like this one?
Indeed, Lady Ada. Exactly like that rather large analog multimeter. When is that from?
This one was made in the 1960s, but multimeters were first made in the 1820s. But not much has changed since then. There's still a large display up top, a mechanical dial to select modes, and 2 wire leads to connect to your circuit.
So do people even use analog meters anymore?
Absolutely. I really like analog multimeters because the moving dial makes it easier to see patterns in your circuit, easier than a digital multimeter.
The simplest way to use a multimeter is for testing continuity, whether 2 points are electrically connected to one another. This is great for checking for solder bridges or cold solder joints within a circuit. Just make sure the circuit is unpowered before testing. First, turn the dial to the continuity setting. Then, connect the black lead to the common ground terminal and the red lead to the rightmost terminal. Then, connect the leads to each point in the circuit we want to test for continuity. If the multimeter detects connectivity between those 2 points, an audible beep will occur. If not, then no beeping shall occur. No beeping.
Here's my Lady Ada tip for using continuity mode in a multimeter. Especially in a loud office, you can't hear the beep. Cradle it against your ears, and that way, when you do a continuity test, you'll hear it nice and loud.
Nice. To measure the resistance between 2 points, set the dial to the lowest resistance setting, and then connect each test lead to each test point. If the multimeter simply displays the numeral 1 and a decimal point, that means we're trying to measure a resistance beyond the range of our current setting. Keep increasing this range setting until you see multiple digits appear. The dial is set to k ohms, or thousands of ohms, so we have a resistance of 9.88 thousand ohms. It's a lot of ohms.
You may find yourself needing to measure the resistance of a very small component, like the surface mount resistor here, and these multimeter probes are way too big. In that case, we suggest smart tweezers. Smart tweezers are basically a small digital multimeter, except instead of wire probes, there's 2 pointy tips. Grab the component with the 2 tweezer tips, then you can read the value off of the LCD.
Testing voltage is similar to testing resistance, but first we need to set the meter's dial to either a DC or AC voltage range. Here we're testing a battery, so we'll use DC ranges. Since I know this battery is supposed to provide 9 volts, I'll choose the smallest range that's larger than 9. Which is 20 volts. It appears this 9 volt is not quite living up to its name, with a reading of around 4.3 volts. Sorry buddy, you don't have to go home, but you can't provide current here.
Don't forget, if you want to measure voltage inside of a circuit, it has to be plugged in and powered. If I have to measure a lot of voltages in a circuit, I like to use a probe multimeter. After you connect the ground contact, you can probe any voltage you want and see the result on the LCD.
Measuring current can be a little tricky because we need to route electricity through our multimeter, and it can only handle up to a maximum of current before blowing one of its internal fuses. The terminal on the right can handle up to 200 milliamps, and the terminal on the left can handle up to 10 amps, but it's not good at reading very small values. If you're unsure how much current you'll be measuring, but you know it's below 10 amps, connect to the 10 amp terminal and to the highest amperage setting. Then make a break in your circuit and connect the test leads across that break. It's showing 20 milliamps. That means I can safely switch to the 200 milliamp terminal and to a lower range. Now I can see that our LED is using about 15 milliamps of current. And my internal fuses are safe and sound.
It's pretty common for people to blow the fuse on their multimeter when testing current, but luckily it's really easy to replace. Start by turning off the multimeter and removing the leads. Unscrew any screws in the back and open up the battery case. There might be some more screws you have to undo. Then turn it over and remove the body from the plastic casing. You'll be able to see the 2 replaceable fuses inside. Check which one's blown and go to your local hardware store for a replacement.
Those are the essential things that you can measure with a multimeter. But many meters also offer the ability to measure capacitance, frequency, or even temperature. Still others have evolved to be quite small and portable. Now, if you'll excuse me, I'm off to do a bit of testing.